velocity profile. This profile is known as what? Velocity profile. And also here, so the profile is can be generated like this. If you are minutely, we just want to analyze the particular liquid flow now by using FEM analysis or whatever the flow analysis. It's a computational fluid dynamics. So nowadays the various trends and technology which can be developed nowadays. Okay. So by using those types of techniques and methodology, if you identify the flow, the velocity profile which can be generated like this. The flow which can be generated like this. If you are taking a SEM analysis, scanning electron microscope analysis in CFD, if you are taking these types of flow, definitely we can get each and every type of liquid, how the different types of density and viscosity will be changing. No, each and every liquid there is a somewhat difference will be there. So likewise, here the velocity profile also which can be generated like this. Okay. So this is the viscosity basic definition. So here the viscosity, there are so the velocity profile based upon the different layer of the liquid. Okay, the velocity which can be varied. So for that only we are using du and dy, the distance. So why dy, which is nothing but the distance between the two layers. Okay. So initial layer and final layer. We can take like that only. Okay. So here the du is the after the deformation of the initial. What is the initial shear stress which can be developed due to the deformation? Am I right? Shear stress to the shear deformation or shearing stress. So it is like that only. Okay. This is the viscosity. Okay. So viscosity which determines the flow of the liquid, resistance to flow to a shear stress. Okay, so that is the viscosity. So in viscosity there are two different types of viscosity is available. So one is the dynamic viscosity. So dynamic viscosity. So here the notation of dynamic viscosity is mu. Okay, so the notation is mu. This is nothing but, so what is the notation here? Tau represent what?
Torque.
Tau. It's not a torque. From here we are using a shear stress. Okay. So tau is the shear stress and du by dy. So this is the formula for dynamic viscosity. So here, so mu is the coefficient of resistance. Okay. Coefficient of resistance of the flow of liquid. And tau which is determined for shear stress. So normally we already know that there are difference in velocity du by dy. So shear stress, which makes to the proportion of shear deformation. Okay, that is called as dynamic viscosity. It is simple. So simple definition is what? Shear stress to make the proportion of shear deformation. So that is, we already know that viscosity means what? The resistance of flow. Am I right? So dynamic viscosity means what? The flow, the normal flow which can be happening like petrol, oil, water, whatever the products, it is the flow will be a normal condition. Am I right? So in that particular flow, how much of the shear stress which can be proportionate to the velocity, the shear difference, shear deformation. It is called as dynamic viscosity. Okay. So the next one is kinematic viscosity. So kinematic viscosity. So here kinematic viscosity which can be represented as mu. So mu is the representation of coefficient of resistance. It will be denoted as dynamic viscosity. Mu which is nothing but what? Kinematic viscosity. Okay. So the kinematic viscosity is nothing but dynamic dynamic viscosity divided by density of the fluid. So this is nothing but what? Mu equal to mu divided by rho. So this is the unit. What is the unit here? So unit of kinematic viscosity is what? Newton seconds per meter square. Okay. So the kinematic viscosity normally in each and every product fluid based applications like petroleum industries, okay, petroleum industry, oil industry. So in those places normally generally we are using a kinematic viscosity by using this equation to find out the viscosity level of the certain fluid like petrol, oil, gas, diesel, like those types of liquids. So in case if you have taken a dynamic viscosity, okay, so normally it will be a very comparatively it will be a high viscosity, the flow, the motion of viscosity. Like if you have taken a jam, if you are pressing the jam from that bottle, the flow of jam it is not a continuous flow. Yes, there is some difference between the oil or water flow and then jam. Can you make a difference between those two? So like the thing it will be happening here. Okay. So this is a very important segments in viscosity. Based upon these two, these are all the very important things. So based upon this we will solve the problems. So not only till that it will be very important properties and also. So the next class we are going to see the Newton's law of viscosity. Okay. Okay. So we will see in the next class in Newton's law of viscosity. Okay. Thank you.